draw like an arrow on the right side. That's P.
Okay.
And then you have to draw weight downwards. So that would be WG.
MG. Just W.
Oh. Oh yeah. Okay. It's weight W, yeah. And then there has to be a reaction force upwards.
Mm-hmm.
Yeah, that's it.
Rough horizontal plane.
Oh, friction.
Yeah. So that will be friction, and it's being pulled along the ground. Yep. Great. Yep, you were good for that. Okay, how about this one?
Mm. Wouldn't the resultant force just be 20 newtons upwards?
Yeah, 20 newtons up. The particle is accelerating upwards.
Mhm.
No exam questions for that stuff. I and J notation.
Yeah, I know how to do that.
Let's see this one. Find the values of A and B. Yep. How about this one?
So the resultant force is just all the forces added together. So
Yeah.
I got 4I plus 3J.
Okay. Part B.
The magnitude is the magnitude is 5.
Mm-hmm.
I don't know what the bearing is.
So you could do a sketch, 4I, 3J. That's 4, that's 3. You just said that this was 5,
Mm-hmm.
and that this is 5. Your bearing, what will this be?
Oh, okay. So you just do 36.9 degrees. Wait, is it in degrees? Yeah.
Yeah, and so if you remember your GCSE bearings,
Oh, it's from north, right?
yeah,
So you have to do. Oh, you have to find that. Okay. So you just do 90 minus 36.9, 53.1 degrees.
50.1 degrees. Hold on.
It's 53.
53, sorry.
Yeah.
Something's missing. GCSE bearings.
Oh, 0.53?
Yep,
Yeah.
I hope so. Let's see. Part C, describe the motion.
Um, it's going 4 units across and 3 units up.
I'm going to say it's accelerating on a bearing
Oh, okay.
of
3.1.
0.53
0.53.
with a magnitude of 5 newtons or something. 5 newtons. I hope so. let's take a look. 5 newtons, 153.1 degrees. The particle accelerates in the direction of the resultant force. Yeah, I suppose. So that's just what we said. In general, it's always going to be the resultant will always be the square root of p squared plus q squared. The angle that is made will always be the inverse tan of the I over the j, q over p. Sorry, the j over the I. So it will be theta will always be inverse tan of q over p. And in this case it was a bearing, so it was a bit different. This is what exam question looks like allegedly. How do we do this?
So it's an equilibrium. So that means all the forces add up to 0.
Yeah.
So then you can just like equate them to 0. Then you know. And then you have to do simultaneous equations.
What are your two equations?
2a plus b is equal to 11. And minus a plus b is equal to minus 1.
Yeah, that's great. And then I just put it in the calculator.
Yeah. Or you could just do it by hand.
Nope. You use the calculator, Missy. Don't do any more work than you need to. B.
Oh, you just have to do, so you just add up F1 and F2, but you need to know what, okay. So you just do, well, you know A is 4, so you know what F1 is, it's 8, and then 3 on the bottom. And then you know F2 is 3 and minus 4. So then you just add them together, so you get 11 minus 1. Oh, that's just force 3. But like reverse, okay. And then the magnitude is just 11 squared plus minus 1 squared. Square rooted. So the magnitude is 11.05 or root 122.
Okay. So that's R
the line.
newtons. Is that what you said? 11.05?
Yeah.
And what about, how would you do C?
So it's just Pythagoras, basically.
Is that not what you just did?
Yeah, but it's the angle.
Sorry?
Yeah, but it's finding out the angle, not finding the magnitude.
Pythagoras is magnitude.
Yeah, but part C is, oh, I meant trig.
Yes.
Because it's finding out the angle between R and I. I is the one that goes horizontally. So it's going to be this angle. Okay. Apparently the angle is 5.2 degrees. But that seems really small, so might not be right.
Might be. Did you do inverse tan minus 1 over 11?
I did cos, but...
Why'd you do cos?
Because it says between the line of action of R and the unit vector I, so I just use cos.
Let's see. This was 11. That's minus 1. This one is the I going across, and then this one is the J.
Yeah.
So this angle here is inverse tan of opposite over adjacent.
Yeah.
Why did you do cos?
Because we know what the hypotenuse is. And then I is the adjacent one, so I just did cos.
Oh, okay. So you did cos using the hypotenuse.
Yeah.
All right. Use the ones that they give you, because you might get part A wrong.
Oh, that's true.
5 degrees roughly. Yep, looks good. Looks good. Any questions there?
No.
Grand. This looks similar.
Yeah.
3 forces. That one's removed. Yeah, you'll be fine for that.
That's two exact same question.
Yeah. Well, it's heartening to see, like, hey, you know, they're saying these are the exam questions. Looks like they will be. Find the angle between F2 and I. The resultant of that is R. B is a bit different. How would you do B?
So first you have to add F1 and F2 to find the resultant.
Mm-hmm.
So when you add them, I got 3 plus A in brackets I plus in brackets 2A minus 2J. 2A minus 2.
2A minus 2. I'll just write them in this notation. Okay.
Yeah, okay. And then, you know, it's parallel to 13I plus 10J. So it has to be the same direction if it's parallel. So that basically just means that 3 plus A is equal to 13 and 2A minus 2 is equal to 10. Is that right?
I think you're close. I believe it is 3 plus A would be equal to 13K, where K is some constant.
Oh, yeah, there's like a constant. Yeah. So you have simultaneous equations again.
2A minus 2 is equal to, yep,
10K. So you can just solve to find A.
Yes.
Which is...
You love solving stuff.
Oh, I did it wrong.
What, the minuses or something, was it?
Yeah, one.
Oh, I should have made you do
it. K is equal to 1/4. So A is also equal to 1/4, apparently.
No, no. Let me see this one.
Is that wrong?
They said it was something else.
Oh,
simultaneous equations 2.
I can't solve simultaneous equation.
13 minus 1 and 3. 10 minus 2 and minus 2. A half and 3.5.
Okay. Yeah. Can't solve.
Okay, calculator from now. A half. So that was the 3/5. Is that right? Yeah. No. That was
it was
half.
Half and 7/2.
And that was the 3.5. Yeah. 0.5, 3.5. 3.5. Wait. You
just need to find A. You don't need to find anything else. So.
Okay, right. Yeah, so just watch out for that K
Yeah.
part. Let me just go back. Yeah, so just watch out for that K. If they're parallel, it'll be that times something.
Hmm.
The resultant is R. Okay, try this one.
I got K is equal to 3.6 and A is equal to 3.4. Okay, that's wrong.
Let's see. Did you? Was your simultaneous equations different to this?
I got 2A minus 3K is equal to 4, but that's all right.
2.
I just did mine differently.
Yeah, yeah.
And the second one, I got the same thing, but I multiplied it by 2, but it's still the same thing.
Why did you multiply it by 2? Because you're allergic to your calculator. Do you know?
For to do simultaneous equations.
So A for equation in your calculator.
Yeah, I know how to do it. I just don't like it.
Why? Why?
I don't know. I just find it easier.
It doesn't look like it. Okay, so 3 minus 2 and minus 4. 1, 1, 7, 2, and 5.
I don't know why I keep getting them wrong.
Calculator. Don't try any fancy stuff. So K equals 2.
Yeah.
Equals 5. So with your values, let me just press exit. So your values, they're all signs are reversed for the first one, are they? Minus 3, 2, and 4.
Mm-hmm.
And then second one, all the values are doubled, is it? 2, 2, 14?
Yeah.
Same thing.
I don't know what I'm doing wrong.
You
Maybe I need to practice simultaneous equations.
don't. Just put them in your calculator. Practicing simultaneous equations, those days are over. Just calculate. It's like finding the square root. Don't need to. Calculator does it. They're expecting the calculator to do it for you. Find the
We
value.
don't have a non-calculator paper in A level, right?
Yep. No non-calculator.
There is no non-calculator. There is.
There's no non-calculator.
Okay, because I know in AS maths you have non-calc paper.
For MEI, there's no calculator.
There's like I think it's like core 1 or core 2. One of them like there's no calculator for AS.
You're doing MEI.
Yeah.
I'll have to look into that. I think they're all calculator these days. They used to be one non-calculator. I'll have to check.
The practice papers I did, like some of them said don't use like no calculator. They were like AS level.
For the entire paper, was it?
Yeah. The papers are like 12 questions though. It's not like that big.
No, I just want to. I'll have to look into it just to make sure because.
I don't think that applies to A level. Only AS papers.
And will you be doing AS and A2 paper?
No, no, we'll have calculator for this one. So
Okay.
this, yeah,
Okay.
for
So
Amox.
so just use the calculator. Let's see this one. That's similar. Very easy. Okay, that stuff.
Yeah, I know how to do that.
I know you do.
Simultaneous equations.
No, you do know how to do them. You just don't want to. Okay, how do you do this?
So Newton's second law is sum of F is equal to ma. So you know F is 6, and then you know mass is 1.5. So then A is 4 meters per second squared.
Yep. And that you're going to use that equation a lot.
Yeah, I know.
Okay, how about these?
Same thing. So, you know, 4. So x is equal to 0.
Nope.
No?
Oh, maybe it is. Yep.
Yeah, it is.
Yep.
And then do you take G as 9.8
Yep.
or 10? Because sometimes they say 10.
Assume 9.8.
Okay. Y is minus 15.6.
Both wrong, I think.
Really?
So y would be positive 15.6. I believe. This one up here is x 0.
Yeah. No, it's 4. No, it's... What would x be?
What take away 4 equals 2 times 2?
Oh, 8.
You go.
So it's wrong.
So just use your calculator. And then this one here, 19.6.
Oh, I forgot to do the resultant stuff.
Q.
Like, which direction? I forgot to include the directions. That's why.
Q. Okay. Right. Redeem yourself, B.
Okay. X is 72 newtons. And okay. If it's not accelerating downwards, do you just not put anything for A?
Didn't say that it's in equilibrium.
Oh.
That means it is accelerating down.
But it's accelerating to the left.
That component will be 0 going up and down, so it won't affect it. So it'll basically be y minus 4g, y minus 4 times 9.8.
Yeah.
Mass is 4. What is the acceleration?
20?
The acceleration will be gravity, I believe.
Oh, okay. Wait, but don't you have to include the 20 newtons that's going down as well?
Sorry, I forgot. I didn't see the 20. So, yeah, that's part of the first one.
Y is 98.4 newtons. Yes. No. Y. It is 0. I was right. Okay.
There is no vertical acceleration. You are right. Why was there no vertical acceleration? There you go.
So it's 59.2, actually. Y.
Okay. Got it. Any questions there?
No, I just have to remember the directions. You have to include them.
Yeah, so if you say down is positive, then all the down ones will be positive.
Yeah.
Or negative, they'll all be negative. Okay, how about this
one? Okay. You have to draw a force diagram first.
Mm-hmm.
So, you know the mass is 5 kg, so the first thing is weight is 5g. And then the horizontal force is 20 newtons, so you have to draw that. And then there's a friction force. 4, and then there's the reaction force upwards.
Mm-hmm.
Since you know that sum of F is equal to MA, then you can just do like 20 minus 4. A is equal to 3.2, I think.
2. Okay.
How do you find the distance traveled by the body?
So you said A is 3.2. We want S.
Oh, you have to integrate, right?
What do you... No, definitely not.
Oh, why not? Oh, it's the acceleration. Oh, the acceleration is constant. Okay. I have to just do that.
Yeah.
So, you know U is 0 because it says the body is initially at rest.
Yep.
You don't know what V is. You know A is 3.2, T is 4.
Yep.
Don't care about V. I don't know the formula because we get given them.
Yep.
So, which one do I use?
It's not U, not V. Which
Isn't there UT plus half AT squared?
S equals UT plus a half.
I'm not sure if that's right, but it might be.
Yep, sounds right.
Yeah. S is equal to 25.6 meters. Oh, you don't know if it's meters, but
I'm going. Yeah. For standard, like acceleration is in meters per second, so it'll be meters. And let's see.
magnitude. Okay. 5G is equal to 0.2 times. I don't get it. How do you find the magnitude of this force?
Magnitude of the normal reaction between the body and the table. I think it's just 5G, is it?
No, 5G is not the reaction force.
Why not?
I got the reaction force as 33 newtons, but I don't know how to find the magnitude.
Because it's moving. The magnitude of the normal reaction between the body and the table.
Oh, wait, I did it wrong. It should be R is equal to 49, actually.
Why is that?
Because it's not accelerating in the y direction, so you have to put A is equal to 0.
Oh, yeah. So what? R
But I don't know
minus.
what the magnitude is. That's just the force.
I think it'll be the same thing because there's no thing.
Oh, yeah.
Yeah,
Okay.
there you go. That's what I said, 5G. Let's see. This one was 3.2. That was 25.6. Yep. Any questions there?
No.
Okay, so you have to incorporate SUVAT. And I'm sure you could do it by integration, but you'd have to draw a graph
Oh, okay.
or imagine a graph.
I thought that only works for when the acceleration is changing,
Um,
because that's why it's called variable acceleration.
that is when you would use it because that's when it is necessary. However, like if you had a graph and it made like a triangle, the easiest way would be a half times base times height, but you could also use integration.
Okay.
It's like, using the cosine rule to find the length of a thing instead of Pythagoras. Like it'll get you the same answer.
Okay.
It's just more work.
But it's more work, yeah. A lift. Yay.
Why is that yay?
I don't know.
Okay, so this time it's probably going up and down.
So 500.
Oh.
You have to add the passenger's mass as well.
Mm-hmm.
So it's actually 800. No, I'm just going to leave it as 500 because otherwise. Yeah, you need to use SUVAT again.
Okay.
So S is equal to 5. U is equal to 0. V is equal to 3. You want S, and you don't care what T is. So V squared equals U squared plus 2AS. A is equal to 0.9 meters second squared. Sorry, meters over second squared.
Sure. What else?
5 times A.
Pardon?
The tension if the lift is magnetically downwards. I got T is equal to 7,120 newtons, which might be wrong.
Seems fine. How about C?
8,560.
60 newtons.
They're meant to be the same.
No, shouldn't be. 7,120, 8,560.
Yay.
720, 960, 0.9. All good. This looks like the same thing. Straight line. Resistance, the acceleration, and the tension. So this is left and right, very similar to the one we did here.
Mm-hmm.
And I think you're fine for that, am I right?
Yeah.
I think you're fine for it. I think you're fine. So there's a little something extra in this one. How do we do this?
So the force diagram first, always. So you have 400G going down.
Mm-hmm.
You have 200 going left. The resistive force.
Mm-hmm.
And then you have another force, like the driving force, but you don't know what it is. And then you have reaction force, yeah, on top. I think you would use Suvat
Mm-hmm.
to do how long it takes the van to stop.
Mm-hmm.
So you don't know S, but U is 16 and V is 0.
Mm-hmm.
You don't know what A is. But you could find A, because you have a force diagram.
Mm-hmm.
So you do D minus 2.
We don't know the force, is it?
Yeah.
Okay.
You could probably do it the vertical way, though. But then you would just have A as 0, so it's not that useful.
It's a different direction as well.
Huh?
It's a different direction. It's a perpendicular direction, so the horizontal component will be 0.
Why would the horizon? Wait, what?
Basically, the vertical acceleration won't affect the horizontal acceleration.
Okay, but it's not accelerating vertically.
Yeah. So
So A would just be 0. So if you did.
So the vertical acceleration is 0, but that
Yeah.
doesn't affect the horizontal
Yeah.
acceleration.
I don't know how to do this question.
You love making me think. Let's see. So it's 400 kilos, cuts out when it's moving along a straight horizontal road. U is 16, V must be 0. S, we don't know. T, we don't know. A, we don't know. Well, part A tells us to find T first.
Yeah. Because then the next one is find S.
Find T, find S. So therefore, there must be some way of knowing A. Is F oh, hold on. The engine cuts out. So F is 0, I believe.
Oh, okay. Oh yeah, there's no driving force.
Yeah.
That makes sense. But so it's not accelerating towards that way. No, it is. Okay.
So it's decelerating until it reaches 0.
Yeah. So minus 200. So A is equal to minus a half.
Mm-hmm.
Then you don't want S, but you want T. So V equals C plus AT. T is equal to 32.
Mm-hmm.
And then you can find S. I got S is equal to 256 meters.
Mm-hmm. And I use the simplified formula.
Suitability of the modeling assumption. I don't know what that means.
What did the model assume?
That the brakes weren't applied.
Read the question. Where does it say model? Where does it say assume or assumption?
Oh, the van is subject to resistive force.
Mm-hmm.
That's the assumption.
Okay, so
There might be like the resistive force might be bigger or smaller, or might not exist.
I would say the resistive force will not be constant. The resistive force will
Oh,
be variable.
okay.
How will it vary?
Because the driving force is changing, so the resistive force will also change.
I'd say it's stronger when the van is going faster.
Yeah.
Moving faster, and then obviously less when slower. Weaker when slower. Weaker when slower. So if they ask you to comment on the assumption, just read through to see what assumption was made. Air resistance is unlikely to be of a constant magnitude. It is usually a function of speed. Okay, yeah. 32 seconds, 256. So that's basically saying...
okay. That is air resistance. Never mind.
Yeah, so that's the resistive force they were referring to.
Yeah.
Okay. Sorry, any questions there?
No.
Yeah, you're fine. Let's see this one. Is this worth doing, or you think you'd be okay? Yeah, we better do it.
K is equal to 120 newtons.
Okay.
Wait, S equals U plus V over T is the actual formula, right?
U plus V over 2T. So that's one of the formulas if you know
Oh,
U, V,
over
and T.
2T. Oh, okay. I thought it was over T. So, oh, wait, that's the wrong formula. Ah, I need the formula book. Oh, I can just do that formula.
What do you know?
None.
No, like U equals.
Oh, you know everything except S and T. You don't need T, and you need to find S.
What is U?
3.
V
0.
T.
A is 3.5.
And you want S?
Yeah.
So
S.
V squared equals U squared plus 2AS.
Yeah. I looked them up anyway.
Looking.
I never bothered to learn them because we get them given, so there's no point.
Yeah, I don't learn them either. I just accidentally remember them.
Okay, I got S is equal to minus 9 over 7, which can't be right because it's negative. So
Could be
it's,
traveling the other direction.
yeah.
Nope. So
Yeah,
first
it's not 2.25.
So let's see. That was first one was 120. That's fine. At the instant the trolley is moving with speed 3, that
Oh,
U is.
the rope breaks. There's no tension force. What am I doing?
Ah.
But you don't need that for this. Does that mean there's no acceleration because there's no tension?
What's more, there will be deceleration, I believe.
Yeah. So A should be minus 3.5.
I think you'd have to recalculate A.
Oh. Okay.
So 0 minus K, which we said was 120, equals 60A.
So A is minus 2.
Yep.
Okay. That's why.
V squared. Yeah.
Yeah. 9 is equal to 4S. S is equal to 2.25.
Yeah. Minus 9 over minus 4, I believe.
Yeah.
5 meters. Okay, so let's see. When that one breaks, you have to recalculate A. Yeah, because it starts decelerating. Okay, forces and acceleration.
Yeah, I think as long as I'm like careful and like pay attention, I know how to do it.
I think so. Let's see. Motion in 2D. How do we do this?
Well, you know the force and you know the math, so you can calculate what A is.
Particle. Find the acceleration of the particle. So you have to find the acceleration in this form.
Yeah, it's just 1.5 I plus 4J. Wait. Nope, it's not. Sorry. 6I plus 16J. Yeah.
That looks right. And then how do you get magnitude and bearing?
Magnitude is square root.
Yeah.
Squared plus 16 squared.
Yeah.
And
right.
yeah, draw a triangle. Same thing. Add them all together. Then.
Yeah, be alright.
Yeah. Yeah, that's fine.
Okay. See this one.
Well, we just did a load of these.
Yeah. Let's just watch out for that one. Two forces. Very similar. The value of B. Would you know how to do that?
Oh, wait, R acts on an angle, right? Does that mean like if you draw the force diagram, then R would be at like 45 degrees? Is that what that means?
Yep.
Because we only did, like when the force is at an angle, we did that like this year, so I don't think it's in our mock.
I just want to make sure about this one. I don't think that's what they're referring to. Let me just check.
Oh,
Particle mass where it starts from rest and is acted upon by a force. So I suppose it's an angle.
yeah.
Or acts on a bearing of 45 degrees. And so how would you find B? You won't need the stuff you're thinking of for this.
Hmm?
How would you find B?
I don't know.
How do you usually get the bearing?
90 minus the angle.
90
So it's just
minus.
55.
I believe it's usually 90 minus inverse tan B over 6. And that gives you 45.
I've seen this before.
You've never seen it before. You were just doing these. So you know how you do inverse tan of Q over P. So this time they just gave you what the bearing is, and you just have to work in reverse to find what one of them was. So you would just solve that one. The magnitude of R would be Pythagoras once you know what B is. How would we do D? You might have to do all the previous parts to get that.
Yeah, you need Suvat for that.
Might be actually. So that. Do I have D? Oh, tell me I have D somewhere. No. Okay. Particle of mass 2.5. 3 forces. Given that the particle is accelerating at this rate. How would you do this one?
You know what mass and acceleration is, so then you know what F1 plus F2 plus F3 is equal to. And then you can just find P, Q.
Yeah, I think you'll be alright.
I don't think we need to do these angle questions.
They're not.
Nothing that we learnt this year in kinematics is in our mock. And we learnt the angle thing this year. I didn't understand it, but
I think you're thinking that these are harder than they are. This is just with acceleration. But okay. So motion in 2D. So after that, it is
this.